When the Halifax-class ships were designed and built, it was well known they were built for 30-year life and could be beyond that. That the kind of technology and equipment they contained would not be in service through their whole life. So we knew at some point at the midlife that we would have to do some pretty significant upgrades and basically modernize it in a way that brings it right up to the cutting edge of naval warfighting technology, ready to actually go into service for the rest of its life. We contracted directly with 2 shipyards to do all the shipyard work, Irving Shipbuilding Industries and the Halifax Shipyard, and the other company being Seaspan on the west coast, albeit in a different yard. And we contracted with a combat systems integrator, Lockheed Martin Canada, to do all the combat systems work.
We started the program in 2008. We were fortunate that we brought a lot of expertise from the original Halifax-class build program called CPF program. And we probably had about 50 employees that had gone through that program in significant roles. So we were able to capture a lot of lessons learned and bring them forward to the Halifax-class modernization. We had another large group of employees that have been doing in-service support for the last 15 to 20 years with the Canadian Navy. And building on those 2 building blocks, we were able to assemble a world-class team, a team that's very capable and at the top of the game for combat systems integration, right here in Canada, built in Canada, and we're really truly a Canadian team.
The fact that they have proven to be such reliable and versatile vessels from the outset, and then to be able to, in essence, re-engineer their fundamental warfighting capabilities at midlife is a real credit to the flexibility of the design. Not just the capability itself and what it means, but our ability to plan, execute, and deliver on a very complex program.
What I found is that people don't realize the size and scale of the Halifax-class modernization program. And the other thing too that I think people don't realize, just for Lockheed alone, the size and breadth of our procurement and our supply chain. So we've had, since the start of the program, we've issued over 700 contracts with Canadian companies. And on average, we do about 1,500 purchase orders a year. So, you talk about scale and volume and the rhythm and having to, to get that done really takes a lot of coordination and discipline.
In some regards, the program was more complex than a new ship build. And the reason I say that is because a new ship build, you don't necessarily have the same constraints that you have of procuring systems and fitting them in an optimal way on an existing platform that has different constraints that a new platform would.
Taken a quantum leap forward in the last year and a half with respect to navigation. Navigation hasn't fundamentally changed since Nelson's time, but what we have now allows us to not only project the ship and our sensors in the future, but actually show where Frigate is going to be, knowing well ahead of time with respect to what we have, how to keep the ship safe navigationally.
Here on the bridge, some of the major changes that we've undertaken are a couple big ones. Number one, navigational radars. We now have 2 navigational radars instead of 1. It's going to change the way we do business from a radar perspective, because what it does is it allows us to better optimize the radars that we have. Example, with 2 radars, I can now optimize 1 radar to scan out 20 miles ahead of the ship, and I can optimize another one for close-in targets. So it allows us better ability to focus on different areas. It allows us to tune things out, like weather, for example, or small crafts that we may not be interested at the time, depending on what we're doing.
Nothing by X-band, nothing by S-band, nothing by AIS. So here we have our X-ray band radar. This is our primary navigation radar, which feeds our electronic charting system. This is primarily a shorter end radar, ranges usually from 6 to 12 miles that we use to keep the ship navigationally safe. It's my primary radar for navigating the ship into and out of harbor, and what we use for the contact picture. This ties in through our multifunction workstation, which you can see here, then feeding the ops room for better fidelity for close-in contacts and for small contacts we may not identify early enough. Now it gives us more battle space to be able to recognize these pictures in different areas, restricted visibility, and get targeting solutions through multiple radar sources. Over here we have the Sierra band radar, S-band radar. This is a longer range plotting aid fitted with automatic radar plotting assistance. Basically we can set zone alarms around the ship so that when we're fighting our ship, we can actually then set for contacts that come inside, sets an auto alarm for the bridge team to identify any contacts closing in a vector with which we want to keep them out. What we have here, this is our ECPINS or ECDIS system, which is electronic charting. It's a digital rendering of nautical charts. Very similar to what a lot of people call maps, but nautically is what we call charts. This shows us exactly where we are in the water, but it doesn't only just do that, it actually gives us a multitude of information. So almost every sensor that we have that's involved in navigation feeds into this. So wind speed and direction, our Doppler speed log, any contacts that we have plotted within our 2 radar systems.
10 miles closing.
Anything that's moving in the water in or around us will then show up on the electronic charting system. So you have real world vision out the windows, which you can then tie in electronically directly onto the chart, identify it as navigational hazards, navigational safety, if it's a contact, where they may or may not be operating based on traffic patterns.
The signal multi-beam acquisition radar for tracking, that's in the S-band, otherwise known as the Smart S 3-dimensional radar. That's our volume search radar, so it's searching out to approximately 130 nautical miles. And it's what replaced our SPS-49. That was our former air search radar. That was a 2-dimensional long-range search. It actually had a lot of restrictions on it. We couldn't radiate it in harbor due to its high power. Nowadays with the Smart S, we can. It is lesser power output, but it's better processing capabilities that gives us our range without the sheer power behind it. So instead of just bearing and range, which previous radars would give us, it gives us altitude. So we can easily differentiate between surface and air tracks, as well as it provides a very, very smooth handover to the fire control system. So the fire control system allows us to shoot at it. So in the event it's a hostile target, the 3D radar is providing very, very accurate data on where that target is. So when the fire control goes to look for it to give us a targeting solution on that particular object, it's quick, it's easy, it's fast.
Ross 200, it's fire control radar. Used to track and illuminate anything that we wish to either follow or shoot down. Missiles, planes, that can be used to guide missiles as well. And often we'll use it even just to identify aircraft that are happen to be flying by fairly low for a visual, because it has a pretty good camera on it.
SG-180, the surface radar. It has a range of about 50 nautical miles and allows us to find surface contacts farther out than the navigational radar. It gives us a more tactical picture as opposed to just a navigational picture.
You can see that it's a dish, and on the back is an IFF antenna, and that allows us to do the identify friend or foe. That helps us determine whether the contact we're seeing is a threat or someone, an ally, I guess.
The biggest upgrade between the SG-150 and the SG-180 is the electronics on the inside. Better processing power, better memory capabilities, ability to track more targets at once.
The multifunction workstation, that's one of the big improvements for the Halifax-class modernization. So there's 15 of them located on board, 14 in the operations room and 1 up on the bridge. And they actually provide the operators both in the ops room and the bridge with the same information. And they can switch between any radar on the ship. So they can view the three-dimensional radar. They can also view from our surface search radar and our navigational radars as well. Instead of just having one screen which is displaying all the information for an operator, there's 3. You can divide your attention. You can have a focus in the center screen of the current tactical situation around the ship. And on the left, you can look at your track data. So that's everything from their bearing, their range, their altitude. That's a big improvement.
We are located in the Command and Control Equipment Room number 3, one of the 3 locations on board for the command management system. The purpose of that system is to amalgamate all the various sensors and weapons into a consolidated picture for the operators so that they can fight the ship.
Ultimately, this is output to displays to the operators, to the multifunction workspaces in the operations room and on the bridge. This is performing things like something called data fusion. So data fusion is one of the big improvements as part of our combat management system. So instead of an operator manually designating targets and looking at data from one radar or another, what they're doing now is the computer is actually looking at various radar targets or contacts that we've seen with our sensors, and they're combining them together. So we have one track, one contact on our operator's console, and this is displaying information from several sources. Now, we can manage this as we need to, we can customize it as required, but the point is we have all the data in one source, it's cleaned up, it's easy to see, easy to use. And again, when you have 100 radar tracks on your operator's console there, displaying at the same time, things get very messy. Time becomes a huge factor. So if he has a single track as part of his display, instead of a couple of them that are all meaning the same object, that's the big deal. It's streamlining his efforts.
All positions EW, new tipper information. 2 times aircraft have taken off the airbase to the northeast.
When you think about the old technology, you're thinking command prompt, like DOS. That was essentially the technology that we're using. And now we're using, a Linux-based system, GUIs. It actually has a much more capable maritime picture, consolidated picture. And the technology used in order to collate all the information from all the various sensors for a picture for the operator is much more robust.
The overall information flow is the same. We still have the underwater on the starboard side of the room, and the above water on the port side of the room, and then the radar and information guys at the forward end of the room, and then the officers who fight the ship are in the back row of the where I'm sitting now. And so all of the information flows into the center of the compartment, which then flows to the operations room officer who sits where I am now, and that is allowing us to fight above and subsurface warfare at the same time. So we'll be dealing with missiles and submarines and torpedoes and possibly even aircraft at the same time.
Have both engines. Set speed 1-2.
The information flow comes through our Shincom system, which is also something that was replaced. And some of the modern features that we have on that is we're able to listen to 4 different conversations at once. So I can pick and choose what information I need to hear at any particular time, including internal and external communication. So I can speak on the radio to other ships or aircraft, either straight through our own HF or VHF systems, or I can speak to them through our satellite communication systems. And then I can also speak to the ORO or the commanding officer or the people who are monitoring my sensors for me as part of the same conversation and bring them in and out of it as required.
Okay, what we're doing right now is we're going to put the barrel into this 57mm Bofors gun. Just came back from Sweden, overhauled, and we're about to bring this gun up into the Irving shipyard and put it onto HMCS Charlottetown.
modernization of the 57mm gun included changing it from Mark II to Mark III standard, and that means that the gun is now capable of using pre-programmable or programmable ammunition. So it comes with 6 different modes of operation, from various anti-air and anti-surface modes, and fundamentally it'll replace 2 different ammunition types in the inventory, and the round is programmed as it's rammed, so it lets us move from a surface target to an air target very quickly, which is a flexibility we didn't have before.
Make gun ready. Got a naval on the bridge. Gun ready. 8 system gun. Engage. 8 system shoot.
So the Harpoon weapon system has delivered to the Royal Canadian Navy a increased flexibility in the employment of that weapon. The Harpoon weapon system is now much easier for the operators to manipulate and use, which means that we can get ordnance downrange in a much quicker fashion with much greater detail for where we want to put that weapon.
Take TAC 2586.
The block of the missile itself has changed. So it's an improved, the thing that's inside the canister is an improved weapon itself, but the major improvement is the dialogue or the communications between the command management system itself, the brains of the ship, and that weapon. The evolved Sea Sparrow weapon system in post-HCM frigates have delivered a great improvement in capability. So the major technology changes are with the systems that support the missile, so the fire control systems, the long and short range search radars, and the command management system and how it brings all those pieces together is the major improvement. So the supporting pieces and the brains that control that missile system are where the major improvements were made in the HCM project. Close-in weapon system, or FELEX weapon system, is a close-in point defense weapon that is really a weapon of last resort if all other layers of our defense have failed. I now have the ability to use that as part of a surface defense of the ship, and as well as its traditional role of anti-air warfare last layer of defense. Now what it provides me in the operations room of the ship is I am aware of what that weapon system is seeing itself. There's a greater target information that's being provided to me as part of the command management system upgrade.
MASS is a multi-ammunition soft kill system that you use on board to defeat most modern missiles. It operates in the electromagnetic spectrum between IR, UV, and also radar. It's an off-board decoy that puts up a wall of chaff. It covers 360 degrees to allow the ship to evade any incoming missiles.
The biggest change to the machinery control room, as well as our equipment, is the integration of a system called IPMS, or the Integrated Platform Management System. This system is a modern Windows-based control system that monitors both the machinery on the ship, it can control it, as well as the fire detection and suppression systems. Whereas before, those systems were split into 2 separate functions that could not talk to one another.
The MCR changed 100%. We went from an old, antiquated 286, 186 computer system to a brand new integrated control system that also takes part damage control as well. So we went from doing boards and with chalk pencils to plotting on a computer system that integrates in real time.
Yes, we also had a seawater differential pressure come in low, and
the MCR controls all the machinery for the propulsion plant. It also provides electrical power for all the weapon systems and everything as well. We maintain and provide propulsion, electricity, and all the other associated systems that make the boat go through the water. So out of the 3 credos for the Navy, the float, move, fight, we take care of 2 of it, and that's the float and the move. With that being said, the MCR also does all the damage control stuff, and the damage control side of the house takes care of any battle damage or any emergency damage we have. So what we've gone to now is a completely different revamped control system. It's based off the original design, so everything looks sort of familiar to what we really had. But what we've gained now is we've gained a more responsive, a faster operating system, and we've also integrated the damage control system, which used to be separate. So by integrating the 2, we have real-time updates on propulsion and damage control.
An IPMS, it's essentially a Windows-based communication loop. We have a port and starboard communications nets, which offer us, and these are loops, so therefore they offer us quadruple redundancy. We have consoles, large screen displays, local control positions on the diesel generators, RTUs, and also portable operating units, or POOs as the Navy likes to call them, which are ruggedized laptops that can be plugged in many areas throughout the ship. And the ship can literally be controlled, or the machinery can be controlled from any of those consoles. One of the key parts of the IPMS system is the battle damage control system. Here we have this, what's essentially an electronic incident board, a map of the ship, and showing all of its spaces. If we have an indication of a fire or a flood, it'll show up on here.
So let's say we have a fire in the steering gear compartment, right?
Right, yeah.
Steering gear compartment.
You can actually see what's going on in there.
You can see what's going on in there. I got a fire in the galley. There's the galley.
Oh, that's awesome.
I can see my master engine exhausts.
Yeah.
Right, I can see my forward exhaust. There's my 40MR exhaust. Right.
So as you can see, we're a little bit in a bubble here. And the engineering watch used to struggle a lot with understanding what was going on outside of the ship. They could only see the information, or they only had the information that the officer of the watch would pass down to the engineer and officer of the watch. Now with the cameras giving us visibility to what's going on outside of the ship, it makes it a lot nicer when we're coming into a foreign port, or if it's a nice sunny day outside, to actually get that visibility outside. It certainly does a lot for the morale of the engineering watch to be able to see outside, because we miss a lot of those beautiful entrances into foreign ports like Pearl Harbor or some of the tropical ports that we don't normally get to see. So actually having another camera puts it into context for us.
I feel that the biggest advantage of having this new technology on board the ship is the ubiquitous nature of it, in that there are consoles and monitors all throughout the ship, and any time that somebody updates some information, well, everybody is seeing that updated information at the same time. And this really revolutionizes the amount of, it cuts down on the amount of chatter over our radios that has to go on, and also ensures that people aren't putting boundaries in the wrong place, for instance. If they are, they do know where the fire is, they do know where to send people, and just gives command, the damage control organization, just a much clearer picture more quickly than we'd get it ever in the old ways. In the old incident boards on paper, everybody would be drawing their own thing. An incident would be completed. We'd bring all those boards together, those paper incident boards, and everything would look just a little bit different. Everybody would have just a little bit look different. But here, with BDCS, everybody sees the same picture, and that's just tremendous.
added on the stern flap to try and attempt to increase our fuel savings, to make us more environmentally friendly, and also to make us a little bit easier on the fuel budget.
If you look around the world, even in the public domain, I mean, like modern warships as individual ships, you know, easily are, you know, and I'm talking about warships here, like combatants, like destroyers and frigates, but they're into the billions of dollars. Like they're $1 billion, $2 billion, and beyond for the higher end ships. We're really have taken these ships and modernizing them, and I wouldn't be so quick to say they're a brand new ship coming out, but pretty close to a brand new combat systems, communication systems, the really high-tech bits and pieces. You know, for that kind of money, you would be lucky to actually acquire, you know, 2 to 3 combatants. We've taken 12 combatants, plus all of the sparing and trainers, etc., and brought all that together for that budget. Again, a good chunk of that budget is about also what we called heavy maintenance. And when you think about, you know, the kind of the budget, what it would cost today in the tens of billions of dollars to actually replace these ships, doing this kind of modernization work, which will now see these ships in operations, you know, for another 20 plus years, is well worth the investment.
It is a significant step in the ongoing and continuous evolution of the RCN over time.
I wanted to share with you what I'd say was a real defining moment in my career, and it was here on the Halifax program. And it happened when, during an event where I was an observer to an operational exercise, and they were running a scenario, and it was like watching Kobayashi Maru.
Simple 1, piston set fire, bearing 310.
And there were whistles being blown, people shouting orders. There were operators, you know, with headsets and engaged, and so immersed in executing the scenario.
31314! ISS BQM based on speed flight profile.
And it was at that moment that I realized the power and effectiveness of the system that we designed for the Halifax-class ship. And so as I stood back, you know, I considered, what does mission success mean? And I believe that we've put the most capable and modern system in the hands of the Royal Canadian Navy so that they can be effective in any encounter and situation that may arise. But most importantly, it could bring them home safely back to their families.
Missile away on the trail, make Sam safe.
And that's what mission success means to me.
From an operational perspective, what we've done is not only extended the physical life of the vessels themselves so that we can get another 15 years of useful life out of the platforms, but more importantly, we've reset their operational capability, and that's the essence of the modernization.
Today's event is very much a culmination of years of work by many people here at Irving, by CSPAN on the West Coast, and by countless industrial and government partners across the country. The last of our 12 Halifax-class frigates to come out of this modernization pipeline. Soon she will join her sister ships, many of which are already on station around the world, contributing to global defense and security on behalf of Canadians. This modernization program has given our frigates the innovations and upgrades they need to face today's global maritime environment, where the threats are faster and stealthier than ever before. The crew of HMCS Toronto, they're going to embark that ship today, and they're going to be extraordinarily proud. And this is just another example of the tremendous legacy of shipbuilding that we have in Canada, delivering world-class innovative solutions for our Navy. And I couldn't be more proud as the commander of that Navy to now congratulate the team of HMCS Toronto to embark in their ship.